Hello explorers, I just wanted to put in a little bit of disclaimer to this video. The sound is not the best in this video. I use my lava mic and I think it's not really connected in the right way. I've tried to record this video a lot of times in different settings and with different configurations, but my video recording software in my phone is really buggy and I ran out of time and I really need to find a different application. So sorry for the audio quality in this video, but I hope that you find the subject matter as interesting and that doesn't matter that much. Enjoy! Hello explorers and welcome to the video. And today I'm going to talk a little bit about the web protocol, HTTP. HTTP, the Hypertext Transfer Protocol. And this protocol is used whenever you are talking to anything on the web, when it's a web page, when you get HTML back. So if you go to Google, for instance, or Facebook, those are web pages, and they will give you some material back that you are looking at. And the thing I want to talk about today is the last S here. So if you have seen HTTP, and that is actually an oversight because the specification never said that these codes should be shown, but some people thought it was really handy to be able to actually write FTP and other protocols when you're using them, but the creators of this protocol actually just wanted you to see the address that you are going to. So if you are typing in https://www.google.com, you will get a green bar. And that means that Google had paid for a certificate so you can verify that you actually are at Google. And this certificate in the secure protocol is over something called SSL, Secure Socket Layer, or you have this Transport Layer Security, TLS, which is the new standard. And this comes in a few different versions here, 1.1, 1.2, and 1.3, and 1.3 is the last iteration of this protocol. So if we are talking about the web here, we have us over here, our web browser, our computer, and we have some web server over here. Let's say it's Google, Facebook, or any of those. And we are actually creating a connection directly to this service. That's how we are thinking about it. That's how we are envisioning that this will happen, and this web service might have some service behind it. It might have a database or something that it gets its data from, and that infrastructure is not important to us, but we need to know that. And usually we have our ISP over here, our internet service provider, the people that we bought our internet from, that we connect through. And they might have firewalls and a lot of equipment that they are using. And the company over here has some equipment as well, firewalls and other things, so that they don't get attacked from cyber bullying or something. Many people are actually attacking web services to bring them down, so that's some kind of bullying, I think. And in the middle here, we have a lot of different infrastructure components that we need to go through. And the problem is that we don't know what's here in the middle. So we want to find some way that some people in the middle here can't be eavesdropping on our connection and actually read what we are talking about. That could be bad for business. It could be bad if this is a bank, for instance. Those transactions could be highly classified. So you want to have some sort of security over here, and this is done by what we actually create some sort of a tunnel over here. So we encrypt our connection on this endpoint, and they are encrypting the things that goes in the other direction, and everything that goes over here is encrypted in both ways. And that's the TLS. And the TLS specification has some different varieties to it, a lot of different algorithms that solve this. And when you are connecting to a server, you say that I have this set of algorithms. I want to talk over this algorithm, for instance, or these 5 algorithms. And the server may say, okay, I have 3 of those, so let's take the best one, perhaps. And they negotiate and actually come back with a solution where they find some way to talk to each other, and usually they have some sort of a key that they use on each end. And the server has also a certificate that tells us that this is the server we connected to. This certificate is signed by some authority somewhere that we know about, so we can verify that this certificate is this server certificate. And we could have a certificate to verify ourselves as well, but usually only the server has this certificate, so we know as customers that we are going to google.com and no one else. We get a green bar and we create a connection to them, and when this connection is up, Google knows that the people or person they are talking to over here is the same person every time, because they are talking over the same connection with the same key. And this key and these algorithms used could be very secure or less secure. And in the older specification, there was a lot of not so secure algorithms. And if there were some eavesdroppers in the middle here that could actually look into the connection and change some information, they might do a downgrade attack. So they say, okay, you say that you have these 6 algorithms, but I remove 5 of them because this one I can crack. So the server only knows that you can talk one algorithm now, and the server has no real option then to tell you, okay, we need to talk over this because you, of some stupid reason, can't talk any other algorithm. So we take this very weak algorithm, and then the eavesdroppers in the middle could actually read that data. So in the 1.3 specification, they are trying to remove a lot of algorithms that have been known in the past to be very bad and very non-secure. So they're trying to actually create better connections. And one of the things that are built into the 1.3 specification is that the key that are created here should be for one-time use. So when you have used this key, you throw it away. This means that every connection or every information that goes over the wire has a key that is temporary and will be removed often. And that means that the communication here between the different endpoints will not be known in the future, because, well, you could keep the packages in the middle here, but you can't actually know anything about them because the server and the client has thrown away the key to the castle. So, and that's a very good way to keep things very secure. So that's a very easy way to explain the new changes and the new nice algorithms. The problem is that some large companies have some things that they need to debug or to look into in their infrastructure to actually make a secure service. So they need to look into the packages before they reach the web service. And that's very hard to do with this implementation, because you have a guarantee that you are talking to the web server and no one in the middle are listening to your communication. And the way they propose to do this is perhaps that they will create keys that they know about. So they will go in and say, okay, you use this key now, so now I want you to use the key 1, 2, 3, and we say, okay, we have to use 1, 2, 3 because the server has said that that's the key we have to use. And these keys are kept for some period of time in order to do this debugging or this monitoring or other functions that the server maintainers might have on this side. And perhaps there could be the same issue on this side. I haven't heard about any service providers that want to be able to look into the information for some reason, but there could be some companies on this side also in the discussion. And in the discussion there have actually been 3 quite hard standpoints in different directions. We have the purists that say the first option here. The purists say that we should have perfect connections. Nobody should be able to eavesdrop on us. Everything should be perfect. And then you have the companies that say, but we need to have some way to look into the data. So that's the second very strong force here. Large companies that actually are in the debate and say that we need this. So we suggest that we do this and this and this to change the protocols in some way. And then you have the third part here, some security professionals that say, okay, we want the perfect way, and we understand the company's dilemma that they need to actually have this data for some reason. And we say that let's do a compromise, that we try to figure out everything that a company might be required to do in their infrastructure and everything that they require to do their job. And then we take some security professionals and they will actually look into the problem and find a solution that is as least bad as possible. So we will try to find a compromise where we don't have this perfect security between the two endpoints, but we find some way to eavesdrop on it, but in a secure way as possible. And that could be a lot of work, and that could delay the 1.3 specification by a lot, because creating a leaky boat that doesn't go under is very hard. So yeah, I'm not having a real standpoint either way how you must do this, because I don't have that much information about how different infrastructure are built in large companies. I have created semi-large construction of infrastructure in companies, but I haven't worked with these really large solutions yet, so I don't know which different applications where this snooping could be beneficial to debug and find problems in your infrastructure. So if you have worked with that, please give me a comment. Please comment and tell me what solution you think should be done with this, and where your standpoint is. I would really like to see some perfect security, and that we can do as good security as possible, but then again, we need the internet to work. We need to have all the different stakeholders to actually be able to use the system and be able to use the protocols that we create. So there's a little bit of a problem with this, but of all the solutions. So yeah, give me a comment. Tell me what you think. I hope you learned something with this video. I really hope that you found it interesting. subscribe if you haven't done that yet, and I really hope to see you in the next one.